So now we're going to continue on with the third topic and start also actually the fourth topic. So talking about the scientific method, which is one of the next topics in your book. And you've covered the scientific method probably a number of times throughout your years in schooling. So we're not going to spend a ton of time on this. But one thing that we're going to spend quite a bit of time on is talking about what does the word scientific mean? And how are we using it, and why is it important? But I do want to start with a review of the steps in the scientific method. So you're going to want to go to Red Packet page 8, which has a doodle note sheet where you can fill in a number of terms and words as I go through it, and you're free to color in as I'm talking. So up at the top, we have a section up here called the question. So there are many different steps in the scientific method, and you can see here we've got arrows going back and forth between sections. Sometimes you can go forward from one step to another. Sometimes you can actually backtrack depending on what you do. So sometimes you ask a question, you start doing research, and you're like, oh, well, maybe I need to change my question a little bit, and you back up. So this kind of gives a very general overview of the scientific method and how it's used. And I think it's a pretty good representation of everything that's considered there. So the process starts when you ask a question about something you observe. Questions can be why, how, when, what, and it needs to be something that's testable. If you have something that is not testable, you can't go any further. So then the research steps say don't start from nothing. Research what is already known about your question, learn from others who may have already conducted experiments, and your question may already be answered. So there may not be any actual experiments or data collection that you need to do. So then if there is additional things that you need to do, you probably want to form a hypothesis. So a hypothesis is an educated guess about the answer to your question. It allows for a prediction. It needs to be easy to measure and not based on non-testable opinions. So opinions are what kind of get us into trouble when we're doing scientific experiments, and opinions really don't have a place when you're truly trying to follow the scientific method. So when an experiment is designed to test your hypothesis, it should be a fair test with appropriate variables and should be repeated by you and be able to be repeated by others. You've probably heard quite a bit about some scientific evidence while we've been facing the pandemic in the spring of 2020 and summer of 2020, and first pieces of information were coming about certain medicines that were working in certain cases, and then other researchers couldn't reproduce it, or a vaccine that looked like it had promise, but it didn't have good reproducibility. So this is part of the scientific method in action in our lives right now. So it is very important that you have provided enough information about your tests so that others could repeat it. So then you want to collect some data. Collect all of your data and observations in a journal, record it accurately, and don't try to make it fit your hypothesis. You really want to use the correct measurements. You don't want to fudge your data. Even if you know something isn't right about your data and it doesn't make sense, well, that means that you've got to rethink your hypothesis a little bit, or maybe rethink the variables. But don't try to force your data to fit what you believe was going to happen. Analyzing. So you're going to want to organize and analyze your data. It may help to use a chart or a graph to help you visualize the data. And you're going to want to ask, did you get any unexpected results or errors? It's always a good idea to go back and take a look to try to discern if there's something that was unexpected. Conclusion. Developing a conclusion is the point when you reach a determination about your hypothesis. Was it right or wrong? If it was wrong, you may go back and revise it. And it may mean that you need to do another set of experiments just to verify that this is going to hold true always. So report. Regardless if your hypothesis was right or wrong, you now have information that's worth sharing. It could be through a report to your classmates or a science fair project, or even being in a scientific journal. So I anticipate that for the most part, all of this was going to be very familiar to you. There's nothing really new here for you because I anticipate all of you have studied the scientific method previously. So in your red packet, you have a page here that I'd like you to fill out. It is page 9. There are a couple of questions here with different parts. So you're going to want to read through the information there. You're going to do questions 1 and 2 and all of their parts. And I am going to say that you do not need to do the making distinctions question that is there on the bottom. While it does have a lot of benefits to doing it, if I'm not there in class, it's not really something we can discuss. So for right now, I'm going to ask you to do questions 1 and 2 and their various parts on here. So I'm going to want you to actually, this is going to be the end of this video. I'm going to continue on in the next video with the next part of chapter 1. So you're going to end up turning this in and for this assignment.